Hi everyone. In this video, we will walk you through the steps we took to deploy a machine learning model using XGBoost, Flask, Google App Engine, and Loader.io. The model we deployed is based on a Kaggle competition about predicting movies' worldwide box office revenue. The data consists on metadata on over 7,000 films from TMDB. As a background, the film industry relies heavily on investors and producers' decisions that are driven by the box office revenue predictions like this one. Okay, so we first performed feature engineering in the variety of data available, ranging from release dates to numeric data like the budget spent or text data from the movie's overviews. Then we performed XGBoost, that is a regression and classification algorithm under the gradient boosting framework. XGBoost relies on several decision trees and it is designed for speed and performance. Once the model was created, we used Pickle to serialize it, and later we will load this file to the Google App Engine to deserialize it and deploy it.
Going through the main application code, we have our main.py, which is really most of the nuts and bolts. We have our pickled model, again, the XGBoost, the requirements.txt, which will show which packages need to be downloaded, the app.yaml, which provides to the GCP app engine there are certain requirements, as well as any other static images that we'd like to provide. So here we tested the Flask application locally, and then we deployed it on GCP app engine. First, we'd load the data. Basically, they're stored in these GCP storage buckets, so as CSVs. And so we just point to that and we'd load those in. We already have the pickled model as a pickled file, so we just load that as well. And then some of this other information is necessary in order to find the poster images from our GCP storage bucket. The main method here is predict, and so when the user enters the movie name and clicks on the predict revenue button, this will run. So for that given name, it'll pull it in, and then we'll use that name to subset our data frame to just that movie. And if it's in the training dataset, then we already have the actual revenue along with our model's prediction. So we subset it, we get the different information. The poster, again, we get the file path with the JPEG from our GCP storage bucket. We get the budget, release date, the runtime, the tagline, and then we run our model and predict for that value to get our predicted revenue. And we round those and both those provided to the user. If the movie is in the testing dataset, then the only difference is we don't have the actual revenue, but everything else is the same and returned. And if the movie is not in our dataset, then everything is empty strings, and we return that the movie is not found. We also have the results method, which is essentially the same thing, but this is if the user wants to get a JSON object. So they hit the predict revenue, return JSON button, and it'll get the same thing. It'll run everything the same, but it'll give you this JSON of the predicted revenue and the actual revenue. And so going over to the dashboard itself, you can see here that we've deployed it on App Engine. This is from our load testing.
And for the final part of our project presentation, we'll do a quick overview of the web application that we built and specifically look at the user interface and the front end. So if we go to the website, the URL, you can see it populates this front end. So we could look for a movie that we trained on, actually. So we would look at Whiplash, and we can predict revenue. And what it will do is show a little bit of information about the movie, and it'll show the actual box office revenue, which is the ground truth value, and then the predicted revenue, which was a training prediction value, and a little bit more information about the movie. And we can search another movie, which we didn't have in the training set, like Inception. And again, we'll see information about Inception. You can see it's not in the training data set that we had in our database, but we're able to make a prediction based off of the features that we trained our model on. If someone wanted to interact with this web application and get the results as a JSON payload, we could also do predict revenue, receive JSON down here. And that, as you can see, will take you to the actual revenue if it exists and the predicted revenue. And if we go back, we could just try one more thing that we added. Say we just kind of put in some gibberish here, not a real movie, obviously, and we predict. The tool is built to accommodate movies that do not exist or misspellings, and we'll tell someone that that is not found. So that is the front end that we used, and we wanted to make sure that this tool worked or could work under certain load test parameters. We decided to use Loader.io, which is a third-party load testing software as a service. And as you can see, the load test that we performed looked at 10,000 clients over 15 seconds, and we had an average response time for our application of about 200 milliseconds, and we were able to make sure our application could handle that load of web traffic and requests. And here's the dashboard analysis of that. All right, thanks for listening. Bye.